Okay, your grade A mathematics teacher Beatrice here. Today we are talking about conditional probability, and we'll also talk about total probability rule. So conditional probability is what we start with. Conditional probability. So we start by saying that for two events A and B, for two events A and B, the conditional probability of A given B denoted as probability of A given B, which is the probability of A happening given B has already occurred, is given by probability of A given B is equal to probability of A intersection B over probability of B. So the same can be rewritten as probability of A intersection B is probability of B times probability of A given B. So we could label this as 1 and we label this as 2. We could also talk about probability of B given A. Probability of B given A is again probability of A intersection B. As you remember, we said because of commutativity, probability of A intersection B is the same as probability of B intersection A. So instead of writing probability of B given A, we simply write it as probability of A intersection B. This time we divide by probability of A. And then we can still rewrite this as probability of A intersection B is probability of A. It is probability of A times probability of B given A. So this is what we call conditional probability. So if we call this 3 and this 4, it is important to note that what we have written as 3 and 4, 2 and 4, 2 and 4 is what we call multiplication rule for probabilities. It is a multiplication rule for probabilities. So today we have learned about conditional probability, and we have seen that when you're given two events A and B, the conditional probability of A given B, denoted as we have seen here, is the probability of A happening given B has already occurred. And these are the formulae that we use for conditional probability. So we have done that. We have talked about conditional probability in preparation for what we call total probability rule. Total probability rule, which we are going to talk about briefly. So under total probability rule, we usually consider two events. We consider two events, A1 and A2, which are mutually exclusive. They are mutually exclusive and exhaustive. You remember that mutually exclusive events, they have nothing in common, and exhaustive events make up the whole possibility space. So we can illustrate that in diagram form. So we have A1 here, A2, they are mutually exclusive. They do not have anything in common. You can see A1 is separate, A2 is separate. And then we let B be another event, such that, so B will be here. It is partly in A1 and partly in A2. So B is an event such that set B is given by set A1 intersection B plus set A2 intersection B. So now introducing probabilities, we write probability of B is equal to probability of A1 intersection B plus probability of A2 intersection B. And once we write that, we can now introduce conditional probability, because we saw that conditional probability is actually written in terms of intersection of events. So we write this as, so we say introducing conditional probability, introducing conditional probability, introducing conditional probability. We have probability of B is equal to probability of A1 times probability of B given A1 plus probability of A2 times probability of B given A2. So once we have them like that, now we already have total probability rule. So this that we have written here is total probability rule on B given two mutually exclusive and exhaustive events A1 and A2. Now, rules in mathematics are written in general. We don't just have total probability rule on being given two events, A1 and A2, but we can say in general, if A1, A2, all the way to AN are mutually exclusive, they are mutually exclusive and exhaustive. If we have A1, A2, all the way to AN, as mutually exclusive and exhaustive events, and another event B and another event B. So in this case, we can illustrate that in diagram. So we have A1, we have A2, and we have events all the way to AN. And if we have another event B that cuts across, so B is A1 intersection B plus A2 intersection B all the way to AN intersection B. So we can now write this as probability of B is probability of A1 times probability of B given A1 plus probability of A2 times probability of B given A2, and we have all the way to probability of AN times probability of B given AN. So what we have written now here, what we have written there now, this is what we call the total probability rule in general. It is the total probability rule in general. So we would like to look at an example that we can solve using total probability rule, and this is our example. So we write it here. It says suppose 10% of men and 5% of women suffer some form of color blindness. So we say a theater audience consists 60% men and 40% women. So we say, what is the probability? What is the probability that a randomly selected individual will be colorblind? That is the question we need to solve, and we are going to solve it using the law of total probability. And why is it so? We are doing so because we have a set of mutually exclusive and exhaustive events. That is, the event of being a man and the event of being a woman are events that are mutually exclusive. They are also exhaustive in the sense that one cannot be a man and a woman at the same time. So we have the set of men and the set of women, and in both cases, some men are colorblind. We are told 10% of men are colorblind. So the percentage of colorblind will be 0.1. The percentage of colorblind women will be 0.05 because we have 5%. So we want to get the probability a person is what is the probability that a randomly selected individual will be colorblind? So, probability, the set of colorblind consists of men who are colorblind plus women who are colorblind. So you can be a man and colorblind, you can be a woman, at the same time you are colorblind. So introducing probabilities, we have probability of being colorblind is probability of being a man times probability of being colorblind, given that you are a man, plus probability of being a woman times probability of being colorblind, given that you are a woman. So we have these probabilities right here with us from the diagram that we have. The probability of getting a man in the set is 0.6. The probability of getting a colorblind man is 0.1. Plus, probability of getting a woman when you randomly select from the group is 0.4. And the probability of getting a colorblind woman is that. So putting that together, we get that if a person is selected at random, the probability that they are colorblind is 0.08. So that is how we apply the law of total probabilities in solving problems. Next time, we are going to see a theorem that is related to the total probability rule called Bayes' theorem. Thank you.